two conductors identical in shape and size. Two conductors identical in shape and size, but made of copper and aluminium, but one of copper and the other of aluminium, which is less conducting, are both placed near a charged body. Two conductors identical in shape and size, but one of copper and other aluminium, are both placed near a charged body. In which metal more charge will be induced? In the diagram, a charged body of charge Q is placed at the point O, and the two identical bodies made of copper and aluminium having initial charges Q prime and Q double prime are placed at the point A and B. The body which is placed at the point A is made of copper and which was uncharged, and the body which is placed at the point B is made of aluminium, and this aluminium body had the initial charge Q double prime equal 0. Both the bodies were uncharged, and in the final diagram, obviously the copper body will have the induced charge Q prime, and the aluminium body will have the induced charge Q double prime. Q prime will be the induced charge or maximum induced charge to the copper body, and Q double prime will be the induced charge to the aluminium body due to induction. When two conductors identical in shape and size, but one of copper and aluminium, one of copper and the other the body of aluminium which is less conducting, bracket closed, are both placed near a charged body, are both placed at the points A and B near a charged body with a charge Q, near a charged body of charge Q, comma, a charge in opposite nature will be induced. A charge in opposite nature will be induced to both the conductors made of copper and aluminium. A charge in opposite nature will be induced to both the conductors of copper and aluminium with respect to the charge of the charge body at the point O. This is the diagram. We have to consider the diagram again. Let Q prime and Q double prime be the induced charge to the identical conductors made of copper and aluminium. Q prime and Q double prime be the induced charge to the copper and aluminium body after induction or due to induction. Therefore, Q prime equal minus Q, bracket open, 1 minus 1 by K1, where K1 is the dielectric constant of copper. Q prime equal minus Q, bracket open, 1 minus 1 by K1, which is the maximum induced charge to the copper body. Q prime equal minus Q, bracket opened, 1 minus 1 by K, bracket closed. That is the maximum induced charge to the copper body of dielectric constant K1. Again, Q double prime equal minus Q, bracket open, 1 minus 1 by K2, 1 minus 1 by K2. Q double prime equal minus Q, bracket open, 1 minus 1 by K2. That is also the maximum induced charge to the aluminium body, to the body of aluminium of dielectric constant K2. Maximum induced charge to the body made of aluminium with a dielectric constant K2. So Q prime is the induced charge to the copper body and Q double prime is the induced charge to the aluminium body. Now copper and aluminium both are metals, and they have the dielectric constant, and their dielectric constant will be infinity. Copper and aluminum both are metals and their dielectric constant are infinity. Therefore, K1 equal infinity and K2 equal infinity. Therefore, what will be the value of induced charge to the copper body? That is Q prime equal minus Q 1 minus 1 by K1 equal minus Q 1 minus 1 by infinity equal minus Q 1 minus 0, because 1 by infinity is 0. Therefore, Q prime equal minus Q only. Q prime equal minus Q, which is the induced charge to the copper body. Similarly, Q double prime equal minus Q, bracket opened, 1 minus 1 by K2 minus Q, bracket open, 1 minus 1 by K2, and K2 is infinity. That's why we can prove that Q double prime will be again minus Q. Same as before, Q prime equal minus Q, and for the aluminium body Q double prime equal minus Q. Hence, both the metal bodies will be induced with equal charge. Both the metal bodies will be induced with equal charges, which are opposite. Which are opposite in nature with respect to the charge Q of the charged body. Both the metal bodies will be induced with the equal charges if the charged body has positive charge. If the charged body has the positive charge, both the metal bodies will be induced with negative charge. Which will be induced with negative charges which are same in magnitude, as that of the charge of the body, charge of the charged body. That is mod Q prime will be mod minus Q, which is equal to Q, and mod Q double prime will be mod minus Q, which is again equal to Q. Also, the magnitude of induced charge. of copper and aluminium. The magnitude of induced charge of copper and aluminium body will be same. The magnitude of induced charge of copper and aluminium body will be same as the charge of the charged body. In the diagram, this is a charged body of charge Q which is placed at O, and copper and aluminium body are placed at the point A and B, and the aluminium is least conducting with respect to copper. The charged body is placed at the point O, and this charge body has the charge q, and the copper will have induced charge q prime as equal minus q, and similarly aluminum will have induced charge q double prime as minus q. So minus q, so if we consider the magnitude of q prime, that is mod of minus q, which is equal to q, and if we consider the magnitude of induced charge of aluminum body, that will be q double prime, mod q double prime will be equal to mod minus q equal q. So now q prime equal minus q1 minus 1 by k. That is the charge induced to the copper body. That is the maximum induced charge to the copper body. And dielectric constant K equal infinity for both the metals, that means for copper and aluminium, K equal infinity. So K equal infinity means dielectric constant K will be infinity for any type of metal. Now the value of dielectric constant for vacuum is 1. That means K equal 1. The dielectric constant K is equal to unity for vacuum. So K equal 1, that is the dielectric constant for vacuum. The value of dielectric constant is minimum, which is equal to 1 for vacuum. And also the value of dielectric constant K cannot be less than 1. The value of K cannot be less than 1.